Hello everyone and welcome to the new devlog of the Astreterre project. I am OraNN and Astreterre is a 2D tactical role-playing game inspired by the Minecraft universe. Today I will present to you the addition of doors, that is to say a system allowing you to go from one area to another with a change of a map. In the previous devlog, I introduced you to the family of what I call activators. These are objects that the player does not see but which allow interaction with the environment. These are markers that detect the player's presence to trigger actions like updating the quest log or spawning mobs. Well, the doors have also become markers that can detect the presence of the player and take him to another area of the game. It is therefore necessary to distinguish between the doors visible to the player and the door markers. The former are sprites and, for now, are just a texture with no animation. The marker is this detection zone visible in the editor with an icon but which the player does not see. These markers can also be used for map borders to move from one region to another without the player needing to see a wooden door. Each door marker has several properties. For example, a door can be locked or not. When the items are functional, a key can be associated with them. You can choose whether a door is consistent or not, that is to say, it is attached to a visible object in-game, such as a house door, or if it is more of a passage point, such as a loading area. Each door also has a destination region. The script looks in the file tree for the area to load when the player crosses it. Finally, each door is associated with a letter which refers to an arrival marker. The arrival markers are invisible arrows for the player, but which define the precise places where it will be placed. Each marker is associated with a letter, which is displayed on the arrow, and which makes it possible to distinguish it from the others. Thus, if there are several doors in the area, we are sure that the player will be in the right place. The arrows also have a direction, up, down, left and right, which allows you to choose the orientation that the player will take once the teleportation is over. The most important of the scripts has been concentrated in the switch node. It will manage the transition from one region to another. In previous devlogs, I had already talked about the reorganization of the main tree of the game to better prepare the transition from one area to another. This new node, therefore, makes it possible to make a small fade-in animation and to manage the deletion of the current region, the loading of the new one, and the movement of the player to the correct coordinates. This node is also strongly linked to the save_load.gd script. It now has the first save game functions. Until now, the game was reset on every start. When you load the test area, everything is reset, such as the presence of creatures. The problem is that this is also the case when you load a region. I wanted to avoid this operation where you kill a creature, you enter the house, and when you come out, the creature is again dashing in front of the door. It was therefore necessary to start studying the principle of saving and loading the state of the regions. Several methods are possible, and I decided, for the moment, to create JSON files associated with each region which saves its state. In the long term, it will be necessary to save the positions of the creatures, the NPCs, the objects on the ground, and other parameters. For now, I'm just managing the life and death of creatures. A dead creature must not be resurrected when returning to the area. The switch script will therefore use functions present in the save load to generate a dictionary that contains the state of all the creatures in the region, dead or alive. This dictionary is then coded as a JSON using Godot's toJSON function. I have already manipulated JSON for the dialog system, so I use a similar principle. I am now using a folder that is placed in the default directory for Godot projects. On Windows, it's the app data folder. Then there is a regions folder, and each region visited will then have its JSONs with its ID plus the _data.json suffix. When the player arrives in a region, the save load script will check if there is already a saved version of the region state. This is basically checking if the player has already visited the area or not. If so, the script will load the corresponding JSON. It is a pass.json function that allows you to transcribe a line of text from the file into a dictionary readable by Godot. In this dictionary, we find information on the state of creatures. I created an ID system for the creatures so that Godot can find an existing creature in the region, even if this identity of the node changes each time the region is loaded. Once the ID has been identified, we analyze the node tree of the scene and we apply the dead or alive state to the creature. She does not appear on the world or participate in combat when she was previously killed. A first backup item works. At this time, this save is only meant to be for the current game. These regions files are not the manual save game that the player may want to save his game. It is on this system that I will begin to work in the coming weeks. It will also be an opportunity to plan a reset of the regions because, for now, if I don't manually delete the regions files in the app data folder, the game will remain ad vitam in the same state. Dead creatures will not be resurrected by cutting and restarting the game. Thanks for watching these devlogs. Feel free to give your opinion in the comments. You can also subscribe to not miss the next devlog. I broadcast at least one stream every week on Twitch and I upload it on YouTube. Thank you to all those who helped the project and in particular to Mimish. See you soon. Bye bye.